Myself R. Shagila Devi, Assistant Professor in Rohini College of Engineering and Technology. Today we are going to discuss about the subject Object-Oriented Programming. In this Object-Oriented Programming subject, in Unit 4, we have the following topics: multi-threading and multitasking, synchronization and inter-thread communication. All these things we are going to discuss in this lecture. So what is the outcome is, on successful completion of this module, the student should be able to compare the multi-threading and multitasking, and they can explain the thread synchronization concept. You can illustrate the concept of inter-thread communication. We are going to discuss about multi-threading. So what is multitasking? Multitasking is a process that it involves multiple tasks running simultaneously. That is, multiple process run simultaneously means that is what we call it as multitasking. OS implements multitasking by using multi-processing concept, and the Java implements the multitasking by using multi-threading concept. What is multiprocessing? A program is a set of instruction. We know that a program is a set of instruction and a process is a running instance of the program. So normally we must know the difference between the program and the process. A program in execution is called as the process. What is a program? A program is a set of instruction. So a CPU is shared between these two devices. So what this is called as multiprocessing. And what is multiprocessing? In multiprocessing, OS implements context switching mechanism. That is, the program's entire context include variable, global variables, methods, etc. But it's stored separately. But in multi-threading, the different tasks within a main task execute simultaneously. The multi-threading implements the idea of multitasking by taking it one level lower. So what is multi-threading? The individual program appears to do multiple tasks simultaneously. Each subtask within an application is called as a thread. So why thread is needed? A thread is an entity within a process. So it defines the path of execution. So what is the need is to run multiple tasks simultaneously to make effective use of CPU. We are using this thread concept. So what is the difference between process and a thread? So what is a process? A program in execution is called as a process. So each process has a complete set of its own variables. But in threads, threads live in a single application, thus may share the same data. In process, it takes more overhead to launch a new process. But if it is a thread means it takes much less overhead to create and destroy a thread. And for a process, the inter-process communication is a heavyweight activity. But in a thread, the inter-thread communication is a lightweight activity. So next we are going to discuss how we can implement multi-threading in Java. So multi-threading in Java can be implemented by using either one of the following approaches. One is by extending the thread class, and another one is by implementing the runnable interface. Okay, so in two ways you can implement the multi-threading concept in Java. One is by extending the thread class, another one is by implementing runnable interfaces. Okay, so next we are going to discuss about the thread priority. Then thread priorities are used in scheduler. So the scheduler schedule the process to the CPU. So threads of equal priority is completely equally for CPU. So we have to give priority to the process. So the scheduler picks up the highest priority thread normally. So how we can set the priority? The priority levels can be set within a range. That is, we can set the minimum priority and maximum priority. So you can, if you want to set, you can set it as min underscore priority of 1. That is, the minimum priority set as 1, and max underscore priority of 10. That means the maximum priority is set as 10. And if you want to set the default priority means you can represent that as norm underscore priority of 5. That is, the normal priority is 5. And next we are going to discuss some of the methods in thread classes: start, stop, yield, is alive, sleep, suspend, resume, current thread, and join. So what is the startup method? A method that makes a request to the OS for the creation of thread is called as startup. So it is responsible for transitioning of a thread from a bound state to the ready state. And what is the use of stopper function? It forcefully kills the thread. It avoids a normal ending of thread. It forcefully kills that particular thread. That is stopper function. So it sends the thread to the dead state. Once a thread becomes dead, it cannot be started again. And what is the use of yield of function? As it is a static method that causes currently executing thread to yield the control. So if there are other runnable threads whose priority is at least as high as this thread, then they will be scheduled next. Again, everything in this depends on the operating system. All the scheduling concepts, priority, everything is based on the operating system's concept. And is saliva function. It returns true value if the thread is started and not yet terminated. If it is alive, that is, the thread is started and the process is not yet terminated, means the is saliva function returns the value true. So if a thread is dead, means it returns the value false. So what is the use of sleeper function? As it is a static method that sends a thread into a sleeping state. So a thread remains in the sleeping state until the sleep time interval is over. So the time interval is specified in terms of milliseconds. So we are going to give some milliseconds. For a particular milliseconds of time, the particular thread is going to the sleeping state. And suspend of resume of function. So what is the use of suspend of function? It sends the thread to the suspend state, and that is after the process, the sleeping is over, actually the resume of function resume back to the ready state. So next, what is the use of current thread of function? What is the use of this particular method is, this method returns the reference of the currently running thread. So it gives you the details about, that is the reference about the currently running thread. Okay, so how we can use this thread dot current thread of, which is equal to T1. That is, we are checking whether it's T1, thread 1 means we are going to do some process. And join of function. So it waits for the thread to terminate. Next we are going to synchronization. So what is synchronization? Many times two or multiple threads need to share access the same object. So this needs to ensure that the object will be modified by only one thread at a time. So else they will be false in race condition. Okay, so if you are using a shared variable, means the shared variables or the shared object must be modified by only one thread at a time. Otherwise it's create an issue. Okay, so to avoid this, we are going for the concept of synchronization. So what is the key to synchronization process? The key to synchronization process is monitors. A monitor is an object that is used as a mutually exclusive lock. It acts as a lock. So only one thread can own a monitor at a given period of time. So when the thread acquires a lock, it is said to have the but that is entered into the monitor. All the other threads are attempting to enter into the locked monitor will be suspended until the first thread exit from the monitor. Okay, so first it gets the lock, means all the other threads should wait. They won't get the access. After this particular thread completes its work, other threads can enter into the monitor. So next we are going to discuss about inter-thread communication. So what is inter-thread communication? Sometimes in an application there is a need of two or multiple threads interacting with each other. So it leads to inter-thread communication. So if an application need to communicate between the threads, means we need the concept of inter-thread communication. Example is a communication between through two threads, like the producer and consumer problem. Okay, so if a producer and the consumer in the same application wants to communicate, means that is the example for inter-thread communication. So to implement the inter-thread communication, there are three methods we are using. One is wait off, notify off, notify all off. So what is the use of wait off function? So it must be invoked within a synchronized context. So when it is invoked, it releases the lock and send the currently running thread to the waiting state. So it give a chance to other threads to look for a same lock. So what is the use of wait off function is? It must be invoked within the synchronization concept. So when it is invoked, it releases the lock and send the currently running thread to the waiting state. That is, it move the currently running thread to the waiting state. Next, notify and notify all of function. So notify function, it wakes up the single thread that that particular thread is in the waiting state, so others can use it. Notify all means it wakes up all the threads. So notify wake up a single thread, but notify all wake up all the threads within the process. And we are going to discuss about deadlocks. So when a thread enter into the waiting state, it cannot be unblocked itself. So the waiting thread can be brought into ready state when other thread notifies by using either notify or by using notify all of function. So if not, it is handled properly, all the threads may go into the waiting state and there is no one to notify them. Okay, so this will create an deadlock issue. Thank you.